Welcome back to part 2 of Module 10, Lesson 5, where we're looking at outliers, and we're going to start this part of the lesson off by seeing how an outlier affects the median and the mode of a data set. So let's get into this. We say the measure of center is a single value that can be used to summarize a data set. The data values that in a table are going to be the heights of the 6 people in line to go through security at the airport. And you can see you've got, this is based in meters. I don't know why they're measuring people in meters here in the US, but these are the heights that they're giving us to start working with. Now, just looking at these problems, I'm going to say that most of these numbers are pretty close to each other. 0.89 is our low point. 1.61 is our high point. But are any of them going to be true outliers? I'm not really sure. So we're going to go ahead and look at it and say, let me make sure there's nothing I missed here. All right. And it says the data values are the heights of the 6 people in line to go through security. Yep, we already talked about that. The solid blue line represents the median, and the green dashed lines represents the mean. So if we take and scroll down here, you can see that the mean was 1.27, which was located right here. The median was 1.28, which is going to be our blue line right here. And you know, just taking a look at those, I just don't think that either one of them, any of those numbers are going to be an outlier. They all look pretty well grouped together, pretty close and easily connected. So what we're looking at here is a data set that does not have an outlier to it, and you can see that the mean and the median, they're pretty darn close to each other. But I wonder what would happen if we were to throw in an outlier. So now the shortest person, the 0.89 meters person left, and the Jolly Green Giant at 2.26 meters came in and took their place in line. How is that going to affect our graph? Well, let's take a look at it. When we put it all on a number line, you can see that something's not right here. Let me see. All right, they want us to take and drag the 0.89 over to 2.26, and watch what happens to the mean and the median. I'm going to drag it over here. We're going to 2.26, which is going to be way the heck over there, right there. 2.26 is the number we're looking for. And now see, you've got a mean that is 1.5, but the median is now 1.43. So before, the mean and the median were only 1/10 of a degree apart. Now the mean and the median are going to be 7/100. Was it 1/10? Let's go back here to that first number we had. Reset. No, I'm sorry, they were 1/100 of a point apart. And then when we take and drag it over to the 2.26, now they're going to be 7/100 of a point apart. So when you throw in an outlier, it skews your data some. It makes it go from being the mean and the median being very close to something that's not really close. And that's why when you have an outlier, we prefer to use the median as our center point for our data. If there are no outliers, then we tend to use the mean as a center point for our data. Moving on to resource number 7, they say that if a data set contains an outlier, the outlier may affect the measures of center. There's no may to it. The outlier will affect the measures of center. Suppose you track the daily temperatures for 1 week. The results are recorded in the table shown. On Saturday, the high temperature is 42 degrees. This temperature is much lower than the other temperatures in the data set. It is also an outlier because 42 degrees is less than the lower limit of the outliers. And they show here that the lower limit of the outliers would have been 59 for this set of data right here. They already did all that math to you. Because 42 is lower than 59, it qualifies as being an outlier. So from here, we're going to take and see how the outlier affects the measures of center. Calculate the values both with and without an outlier as your data. And so with an outlier, we need to actually see our data set, which they've taken away from me. And without the outlier, we need to calculate the mean or average with both of them. So I'm going to take and get a screenshot of my data set, which is right here. And then We're going to paste it in right over here. That's not what I copied. Alright, so with the outlier, I'm going to take and grab ourselves a little Satan. We've got 72 plus 68 plus 71 plus 74 plus 75 plus 72. And when we do that, it equals 432. There is going to be 1, 2, 3, 4, 5, 6 values. So we're going to take and divide that by 6, and that gives us an average temperature of 72 degrees. So jump back over to our textbook, which is right here. We're going to say that with the outlier, without the outlier, it's going to be 72 degrees. Now we're going to take and go back to where we had before, and we had 432 with the 6 of them, and we're going to add that 42 degree outlier to it, and now we're going to take and divide by 7, and when we do that, now we have changed significantly the temperature to be 67.7 degrees. Let's see if they give us credit for that. They're not even allowing me to scroll or change things. Oh, yeah, they say it right here. With the outlier 42, the mean increased in value. Okay, without it, so we went from 72 degrees to 67.7 degrees. So you can see that when we put the outlier in, it really made a significant change in the average. But did it change the median? Not really. The median stayed pretty much the same right up there. In fact, it stayed exactly the same at 72 degrees. Once again, this is why when we have outliers, we use the median for our measure of center, and when we don't have outliers, we use the mean as our measure of center. Example 2 gives us I guess it's a turtle dinosaur looking creature. This has a birthday cake and it's blowing out candles. And it says the table shows the average lifespans of the selected animals. Calculate the mean and the median both with and without the outlier being that tortoise. So that answers a question about what he is, which says it can live 200 years. Then choose the measure that best describes the center. So in doing that, we're going to take and find the average lifespans of the animals is all listed right here. And when they take and do the math on that, we're just going to use a calculator here to save you all some time. I've got 35 plus 30 plus 50 plus 200 plus 30 plus 70 plus 20, enter, all divided by 7 critters. So when you include everything, including the tortoise in there, you're going to have an average of 62.1 years rounded to the nearest tenth. Therefore, the mean lifespan of the animals is going to be about 62.1 years. We're going to check that. That part checks. Now we're going to do the same exact thing, but we're going to leave old tortoise out because tortoise is definitely an outlier in this set of category. Actually, no, we're not. We're going to find the medians. We need to order our numbers from least to greatest. So let's take that over to a different page and work on that for a moment. So we're going to take, this be a good spot, and ordering them from least to greatest. Give me a second here. There we go. That means we're going to start with that poor short lifespan critter that only lives 20 years. And then we have a 30. And we have another 30. And we have a 35. And we have a 50. And we have a 70. And we have a 200. So we have 1, 2, 3, 4, 5, 6, 7. That means that our median score is going to be 35. So we can say that the median age right here is going to be 35 years, which is very different from the 62 years that we came up with when we were looking at the average. Now we're going to do the same exact thing, only we're going to leave Mr. Tortoise out of it. So we're going to take and find our mean or average without Mr. Tortoise, which is 35 plus 30 plus 50 plus 30 plus 70 plus 20. That is going to equal to 235. We're going to divide that by the 6 critters we're looking at now, and that's going to give me a mean or average rounded to the nearest tenth of 39.2. So the mean lifespan there is going to be 39.2 years. Check that. That checks. Now we're going to find the median doing the same exact thing. So I'm going to jump back over to this page I had, and this time I'm only looking at these values right here. Let's see if I can copy and paste that to a new spot. I sure can. And now when I do that, my middle value is going to go right here. So I have to average 30 and 35. That's 30 plus 35 divided by 2, which is equal to 65 divided by 2, which is equal to 32.5. And jump back over to my median again, and I'm going to put in my 32.5 years there, and that checks. Now if we compare those values, hopefully they'll let us do that next. It says which one best describes the center. Well, I'm going to say that the median best describes the center because of the outlier here. The median stayed pretty close to each other, 35 and 32.5 years, but the mean, the average, that sucker really changed. It went from 62 years with the turtle down to 39 years without the turtle. That's the power an outlier has on your measure of center. That is a reason when we're dealing with an outlier, we always use the median as our measure of center instead of the mean. So scrolling down here, we can say that the mean was most affected by the inclusion of the outlier, and that the median changed very little. Therefore, the median is going to best describe what we are representing in our data. Now it's going to be your turn to do extra example 2, where you're going to solve it and find out what the answer of how the price is affected most with the outlier, and which one affected most and which one changed very little. Now the answer should be pretty obvious at this point, but you still need math to prove it. So let's start off calculating our values with the outlier. So when I do that, I can simply take, and we're going to just be lazy on this, we're going to add all these up. And when we add them up, we're going to take and divide by 1, 2, 3, 4, 5, 6, 7 items. And I'm going to use a calculator. I don't mind you using a calculator on something with this many decimals and big numbers. So we're going to take and do 51.95 plus 47.5 plus 46.5 plus 48.5 plus 52.95 plus 78. Oh, missed a 0.95 in there. And then plus 39.95. We're going to divide all that by 7, and if I did my math right, that means the mean rounded to the nearest tenth is going to give me 52.3. And that is, of course, with the outlier. Meanwhile, the median is going to be, let's do from least to greatest. So I'm going to have 39.95 is my first one. Then I have 46.50 is my second one. 47.50 is my third one. 48.50 is my fourth one. 51.95 is my sixth one. My seventh is going to be 52.95, and then that outlier is 78.95. The middle number, 1, 2, 3, 4, is right there, so the median is going to be 48.5. Now that was doing our data with the outlier. Let's see what it looks like without the outlier. So I've taken the outlier out of my set of data, and now we're going to take and calculate up the mean without the outlier being involved in it, which is 51.95 plus 47.5 plus 46.5 plus 48.5 plus 52.95 and 39.95, and this time we're dividing by only 6 values, which means that we're going to have a mean or an average of 47.9 rounded to the nearest tenth, 47.9, and when I compare that to this, there's a pretty big difference between the two of those. If I was to look for the median, however, the median is going to be the average of these two center numbers. So I'll be doing 47.5 plus 48.5 divided by 2. And I'm pretty sure that would end up being exactly 48. But let's go ahead and calculate it to be sure. 47.5 plus 48.5 equals divided by 2. And yes, it is exactly 48. And when you compare the median, the other median we had earlier was, let me go back and grab my grabby tool, this one right here, which we said was 48.5. Now my median is going to be 48. You can see that the median is once again going to be a much more accurate representation of the data when we're dealing with outliers. So it's going to be a lot closer. So we can say right here the price of the mean price was going to be affected the most with the outlier. The median price changed very little. Check your answers. There you go. Get busy working on your homework. Make sure you're giving me good quality supporting work. I gave you good quality supporting work. I will allow you to use a calculator on ugly numbers like this when you're trying to find the mean, because I'm not that mean of a teacher. Have a good day.